Okay, welcome back. So on today's video, we're going to be looking at another method of doing the Laplace transform. And this one, we're going to be talking about convolution. So basically, when we have the product of two functions in the S domain, that it's equal to the convolution of the functions in the T domain. So you can see we have here, for example, we're taking the Laplace of f convolution g, and the Laplace of that is equal to the Laplace of f times the Laplace of g. But whenever we take in the Laplace inverse of f times g, we don't get f times g of t in the T domain. We get convolution of those two functions. So for example, here, we're taking the Laplace inverse of 1 over s minus a times 1 over s minus a times s minus b, which of course we can break up into two fractions, 1 over sa times 1 over sb. So this does not equal the Laplace of 1 over s minus a times the Laplace inverse of 1 over s minus b. No. What happens here is that this equals the convolution of those two Laplaces once you go into the T domain. And we're going to go in a little bit what convolution looks like, the formulas and so on, but just keep in mind that the product in the S domain is not equal to a product in the T domain and vice versa. So in this case, we take the Laplace of each one. We're going to get e to the a minus e to the at convolution e to the bt. And you can see that we use that little star to signify the convolution instead of multiplication. We use the dot for multiplication, that little star for convolution. So the formula for convolution is the following. We have that f convolution g of t is equal to the integral from 0 to t of f of tau times g of t minus tau d tau. So you can see that this is a problem where we're actually going to introduce a little bit of calculus in the Laplaces. So far, all we've been using is algebra, but it's just a pretty straightforward problem. So let's solve it an example. So we have t convolution e to the t, and I label some things in color so you can see where each one goes to. So to start a convolution, we have to, you can see for the first one in green, it will, instead of being a t, it will switch to variable tau. And the second function, it will have a t minus tau. So doing that, I will basically write t as tau. So t is a function, and as a tau, it's just tau. And then e to the t, it's now e to the t minus tau. Okay, everybody following up to now, I hope. So when I take the integral from 0 to t, I will have now t times e to the t minus tau d tau. And if I basically rewrite that exponentials, I will have e to the t times e to the negative tau. And because we are integrating with respect to tau, in this case, that e to the t can be treated as a constant, so I can factor it out of the integral. So I have the following. So I have e to the t times the integral from 0 to t of tau times e to the negative tau d tau, which will involve doing integration by parts of tau and e to the negative tau. I do that, I get the derivative of tau, it's 1, then 0, integral of e to the negative tau, it's negative e to the negative tau, and then e to the negative tau, plus minus, and then I'll get here then that the answer to that integral, it's e to the t times negative tau e to the negative tau minus e to the negative tau, integrating from 0 to t. So I have to do basically the values. I take the integral, I substitute, and what I end up with will be e to the t times negative t e to the negative tau minus e to the negative t plus 1, which basically comes from that e to the 0. I distribute that t, and you can see because the insides they have negative exponents compared to the one on the outside. Once they multiply, they cancel out. And all I'm left with is t minus 1 plus e to the t, which is the solution to that convolution at the beginning. So hopefully you see it was pretty straightforward. You can now really stop, rewatch this video, and follow the formulas to see how it's solved. So we have this other example here. So we have 1 over s squared times s squared plus 1. So we need to solve this one. We can use the formulas. We can use PFD. We can use any method. And listen to this. We're going to use convolution. So I can split it up into two different fractions, 1 over s squared and 1 over s squared plus 1. So I will take the Laplace inverse of each one of those. And you can see because it's a product of two fractions, we can use the convolution in the t-domain. So basically, the Laplace of 1 over s squared, we know that's t, and 1 over s squared plus 1, that's sine of t. So we're going to have these two in convolution. So we're going to select t for tau, and then sine will be sine of t minus tau. Plug it into the integral. And sine of t minus tau cannot be basically integrated like that. So we can use a definition from the appendix in the back of the book. I think appendix 12, appendix 16, somewhere in there. Look for that appendix. And you will get this identity where we have that sine of t minus tau, or sine of a minus b, whatever. It's equal to sine of t times cosine of tau, or the second variable, minus cosine of the first variable times sine of the second variable. So now doing it like this, we can split this into two integrals, where you can see that sine of t and cosine of t, because we're integrating with respect to tau, can be factored out. And then I'll just have to do the integrals or partial integration by parts of t and cosine of t, or I mean tau and cosine of tau, and then tau and sine of t. You can see I did them here on the screen. I will just plug in their solutions. So sine of t times t sine of t plus cosine of t, I mean tau, integrated from 0 to t, minus cosine of t times negative tau cosine of tau plus sine of tau, integrating from 0 to t. Substitute those values. You can see some of them will cancel out because have sine of zeros or zeros. Anything that's not 0, 0, cosine of 0 is 1. So after simplifying everything, getting ready, we have the following. You can see if we multiply, we're going to get t times sine square of t plus sine of t cosine of t minus sine of t plus t cosine square of t minus sine cosine of t. You can see we have sine and cosine plus or minus, so they will cancel out. We have cosine square and sine square. So we can factor that one out from the t. So we're going to have t times sine square plus cosine square minus sine of t. And you can see the sine cosines basically cancel out. We know that sine square plus cosine square is an identity to 1. So all we're left with is t minus sine of t, which is the answer to our original convolution that we had at the beginning of t times t convolution. T ended up just being t minus sine of t. And this is our answer to this convolution. So I hope that this problem was helpful. Once again, this is just another method that we can use. Hopefully we're going to go over some other ones like that in class. But whichever method is useful for you, whether PFD, formula, or convolution, all of them are valid for you to use. So that's it until this video. I'll see you on the next one. And as always, good luck.